Hello class, we're about to start section 6.2, linear equations in one variable and proportions. Objectives: solve linear equations containing fractions, solve proportions, solve problems using proportions, and identify equations with no solution or infinitely many solutions. Solving linear equations in one variable. A linear equation in one variable x is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Solving an equation in x involves determining all values of x that results in a true statement when substituted into the equation. Such values are solutions or roots. We say that a solution satisfies an equation when we substitute the solution into the equation and a true statement results. The set of all solutions that satisfies an equation is called the equation solution set. Two or more equations that have the same solution set are called equivalent equations. For example, 4x plus 12 equals 0 and x equals negative 3 are equivalent equations. The addition and multiplication properties of equality. Before I go here, let me prove this to you. First, let's solve this equation. We have 4x plus 12 equals 0. We will solve for x, so we will subtract 12 on both sides. We have 4x equals negative 12. Then we will divide each side by 4, and x is negative 3. So since this equation is x is negative 3, and we have x equals negative 3, they are equivalent equations. Okay, now we have the addition and multiplication properties of equality. The addition property of equality: the same real number or algebraic expression may be added to both sides of an equation without changing the equation solution set. A equals b and a plus c equals b plus c are equivalent equations. The multiplication property of equality: the same non-zero real number may multiply both sides of an equation without changing the equation solution set. A equals b and AC is equal to BC are equivalent equations as long as C is not equal to 0. It says using properties of equality to solve equations. It says equation x minus 3 equals 8. What would you do to isolate x? Now if you look here, to get x by itself, we would add 3 to both sides of the equation. I'm going to abbreviate equation with EQ, but you know that means equations. Okay, now when I say both sides of an equation, that means both sides of the equal sign. So now solve the equation. We have x minus 3 equals 8. We will add 3 on both sides, and x equals 11. It says the equation solution set, which would be 11, all by itself. And remember, we have to use those braces to indicate a solution set. Now we come to the next problem. We have x plus 7 equals negative 15. To isolate x, we know we will subtract 7 on both sides of the equation. Now the next thing we would do, we would solve the equation. So we have x plus 7 equals negative 15. We will subtract 7 on both sides. And x is equal to negative 15 minus 7 is a negative 22. And our solution set is a negative 22. Now we come down to this next problem. We want to isolate x. So we would divide each side of the equation by 6. So we have 6x equals 30. We divide each side by 6, and x is equal to 5. So our solution set here would be 5. Now we come down here, we have x over 5 is equal to 9. We can multiply 5 to both sides of the equation. Then we will solve. We will have x over 5 is equal to 9. So we will multiply each side by 5. And we could make this 5 over 1. So this will give us 5x over 5 is equal to 45. 5 divided by 5, we know that simplifies out to 1. So that would be x equals 45. And then your solution set here would just be 45. Now, we come to solving a linear equation. Now, to solve a linear equation, we have to simplify the algebraic expression on each side by removing grouping symbols and combining like terms. Collect all the variable terms on one side and all the constants or numerical terms on the other side. Isolate the variable and solve. Check the proposed solution in the original equation. Now, example. Solve and check. We add 2 times the parenthesis x minus 4 minus 5x equals negative 5. So it says simplify the algebraic expression on each side. So the first thing we would need to do, we would do the distributive property. We would take our 2 times x and also our 2 times the minus 4. 2 times x is 2x. 2 times the minus 4 is minus 8. And we bring down our minus 5x and that equals negative 5. We combine like terms. 2x minus 5x gave us negative 3x minus 8 equals negative 5. Now step 2, collect variable terms on one side and constants on the other. So that's basically this. We want x on one side and all of the numbers on the other side. So first thing we would do here, we would add 8 to both sides. And that will leave us a negative 3x equals negative 5 plus 8 will give us positive 3. Now step 3, we're going to isolate the variable and solve. Divide each side by negative 3, the number that's connected to x, and that will give us x equals negative 1. Now if you want to check your solution, the only thing you would need to do is go back to the original equation and substitute in negative 1 for x and solve. If both sides of the equation are the same, then your answer is correct, which we see here. Now, it says because the check results in a true statement, we conclude that the solution set of the given equation is the solution set of negative 1. Okay, it says example, solve the equation and check your result. Okay, so now let's go through and solve this equation. First thing we would do is add 7 on both sides. So we have 5x equals 75. We divide each side by 5. And x is equal to 15, because 75 divided by 5 is 15. So now to check our answer, we will go back to the original equation, and we will substitute in 15 for x. 5 times 15 is 75, minus 7 is 68, and 68 equals 68. So that is correct. Now we go to our next example. It says here the same thing. Solve the equation and check your result. Negative 3x plus 8 equals 47. So we will subtract 8 on both sides. We add negative 3x. 47 minus 8 is 39. Divide each side by negative 3. And x is negative 13. Now that we know that x is negative 13, we will go back and substitute in negative 13 into this equation. So we add negative 3x plus 8 equals 47. So negative 3 times the negative 13. We'll substitute in negative 13 for x plus 8 equals 47. Negative 3 times the negative 13 we know is a positive 39. Plus 8 equals 47. 39 plus 8 is 47. And 47 equals 47. Now, we have this next example. It says solve the equation and check your result. Now, of course, we do this distributive property. We add 2x plus 14 minus 5x equals a negative 25. 2x minus 5x is a negative 3x plus 14 equals a negative 25. Now we will subtract 14 on both sides. And we add negative 3x equals negative 39. Now we will divide this out here. Now we know that we would divide both sides by negative 3. But let me move this down a little bit so we'll have a little bit more space. All right. Now, so we'll divide each side by negative 3. And then we will have x is equal to 13. So now we go back and put in 13 for x. And I'm going to write this over here because there's a little bit more space. So we'll rewrite the problem. So we add 2 times 13 plus 7 minus 5 times 13 is equal to a negative 25. 13 plus 7 we know is 20. Minus 5 times 13 equals a negative 25. 2 times 20 is 40. A minus 5 times 13 is a minus 65 equals negative 25. 40 minus 65 is a negative 25, and that equals negative 25. So our answer here is x equals 13. And we can also write our answer as the solution set of 13 as well. Okay, so now listen, for all of these, we're not going to check every last one of them, but that is very good practice. So what I'm going to do here, going to do this next problem, but this next problem I'm not going to check it. You can check it at your leisure. But right now, I'm just going to go through and solve this problem. So now the first thing we need to do is take the distributive property. We will add negative 6x plus 3 minus 2x is equal to 2 times 6x is 12x. 2 times a minus 4 is minus 8 minus 9. Now we combine our like terms. Negative 6x and negative 2x is a negative 8x plus 3 is equal to 12x minus 17. Now we need to have all the variables on one side. So let's add 8x on both sides to move all the x's on one side. So we will have 3 is equal to 20x minus 17. Now we will add 17 on both sides. So we add 20 is equal to 20x. Divide each side by 20. And 1 is equal to x. Now if you want to check this, you could go back and substitute in 1 wherever x appears. And this is your final answer. Now we come to our next example. Now this example's, we're dealing with a fraction. So let's go through and solve this fraction. It's still the same concept. So now we look here. It says solve the equation and check your answer. We have 2x over 3 plus 5, 7 equals 2x over 9. Now the first thing we need to do, let's move all the x's on one side. So let's subtract 2x over 3 on both sides. So we have 5 sevenths is equal to 2x over 9 minus 2x over 3. Now we have to find a common denominator. The common denominator of 9 and 3 we know is 9. So we'll multiply this numerator and denominator by 3. So we have 5 sevenths is equal to 2x over 9 minus 2x times 3 is 6x, and 3 times 3 is 9. Now we combine our like terms. We will have 5 sevenths is equal to 2x minus 6x is a negative 4x all over 9. Now, again, we're trying to get x all by itself. So we will multiply it by the reciprocal of a negative 4/9, which is a negative 9/4. So this will give us negative 45 over 28 is equal to x. And this is the final answer.